Black holes, those enigmatic and awe-inspiring entities scattered throughout the universe, have captivated the minds of physicists and astronomers for countless years. Their existence holds profound implications, possibly unlocking the mysteries of our very universe and extending into the realm of multiverses. While black holes have long been the subject of science fiction, with captivating tales and movies woven around their ominous yet intriguing nature, recent scientific discoveries have provided a wealth of new knowledge that is challenging the established notions. Scientists have gathered groundbreaking information about black holes, revolutionizing our understanding of these celestial marvels. Serving as the final resting places of massive stars, or as the epicenters of galaxies, supermassive black holes are believed to have originated simultaneously with the galaxies themselves. Undoubtedly, they stand as some of the strangest locations in the universe. While stars endure for extended periods, black holes present a different reality. The burning question on everyone's mind remains, what would occur if one were to fall into the clutches of a black hole? These perplexing cosmic entities invite us on a journey filled with wonder and uncertainty, beckoning us to explore the limits of our knowledge and imagination. They don't live forever and slowly burn to the fuel that keeps them shining. When that runs out, one of three things happens depending on the mass of the star. They will either transform into a white dwarf, a neutron star, or a black hole. If the star is big enough, it will explode when it reaches the end of its life-going supernova and cause the star to cave in on itself. Decreasing it in size dramatically, the outer parts of the star are expelled violently into space while the core completely collapses under its own weight. However, even though the star gets smaller, its mass stays the same and the gravity around the star becomes so strong that if anything gets close enough to it, it will absorb everything. Around this is the black hole we need for our experiment. Thanks to Einstein's theory of relativity, we know that nothing can escape a black hole, not even electromagnetic radiation such as light itself. The term black holes comes not from an astronomer's inability to see a black hole in space, but rather by observing what is called Hawking radiation, the emitted gamma-ray bursts discovered by the late great theoretical physicists and cosmologists Stephen Hawking. Using this technique, it allowed scientists to detect more black holes than ever before. But for the record, the first ever direct image of a black hole was just recently captured on April 10, 2019 by the Event Horizon Telescope. It imaged a supermassive black hole at the core of a supergiant elliptical galaxy, Messier 87. With a mass of 7 billion times the Sun. Since black holes have been discovered, imaginations have run wild concerning them, with theories ranging from the possibility of intergalactic travel, time travel, interdimensional travel, and even the possibility of the existence of a multiverse or alternate realities usually associated with them. But in recent years, these ideas have become less fantasy and have even garnered support in the astrological community as technological advances have uncovered new information about these stellar objects and their mysterious behavior. Not all black holes are created equal. Though the amount of energy released during the supernova determines the mass of the stellar remnants that cause the gravity that forms the black hole. For instance, when a star dies, it must leave behind a mass at least 3 times that of our Sun in order for a black hole to form. Supermassive black holes occur when the resulting stellar remnant is at least 1 in times the mass of our Sun. Black holes like this one may teach us more about the origins of the universe than our understanding of the laws of physics has done so far. Black holes are incredibly interesting objects that we could talk about forever. But you're here because you want to see what happens if you fall into a black hole. So let's get to the good stuff. Journey into a black hole from the first astronomers to witness these cosmic beasts to films like Disney's The Black Hole and Christopher Nolan's Interstellar. Humans have wondered what it would be like to enter a black hole. Spoiler alert, you will cease to exist. Not only will you experience a very strange, near instantaneous transformation, but you will literally be disintegrated into a quantum state that may or may not be able to be reconstituted as matter inside the black hole itself, where the laws of physics do not apply. But enough about these stories and theories, because one thing is for sure: we do know that no matter can escape the overwhelming gravitational field of a black hole. If you were unlucky enough to encounter a black hole and get trapped in its gravitational field, you would experience quite a journey. Despite what our current computational limitations today can tell us, there is a possibility that one can survive a black hole, and experiencing this awesome celestial behemoth would be quite a spectacle to behold. As you approach the edge of the black hole, you will first notice your speed accelerating as you get closer to the event horizon for the point of no return. The gravity inside the event horizon is so great that it distorts spacetime as the black hole collapses under its own weight. However, what happens to you when falling into a black hole greatly depends on its size. Stellar black holes, formed from collapsed stars, have a steep gravitational pull, meaning that the force of gravity changes very rapidly as you move closer. They are much smaller and stretch around 20 to 100 miles across. Near a black hole, roughly the size of the Earth, tidal forces would be magnified off the scale, and you would likely not get anywhere close to the perimeter or the event horizon of the black hole. The gravitational pull on your feet would be much stronger than your head, that you would look like toothpaste coming from a tube, or a piece of spaghetti being stretched. For the record, it was British astrophysicist Sir Martin Rees who coined the term spaghettification, which is a good way to put it, as you would eventually become a stream of subatomic particles swirling into the black hole, and because your brain would disassociate into its constituent atoms almost instantly, you'd have little time to take in the scenery at the threshold of an Earth-sized black hole. But if you are dead set on making the journey into a black hole, the bigger the black hole, the less extreme its surface. For instance, if you had a black hole the size of our solar system, the tidal forces at the event horizon would not be quite as. If you were to fall into a strong Earth-sized black hole, your body would maintain its integrity, but you would experience the effects of space-time curvature predicted by Einstein's theory of relativity. As you approach the speed of light, time dilation becomes significant. Objects that have fallen into the black hole before you would appear to have experienced greater time dilation, while objects that will fall after you would be visible behind you. The Sagittarius A** black hole at the center of our Milky Way galaxy, measuring 27 times the mass of the Sun, would be an interesting candidate for such an experiment. Supermassive black holes, located at the center of galaxies, can be enormous, reaching sizes of billions of miles across. Falling into one would lead to an eternal descent towards the singularity, where reality as we know it ceases to exist. The nature of what lies beyond the singularity remains unknown, and scientists have yet to reach a consensus. Theoretical frameworks like string theory propose possibilities, but testing these theories is currently beyond our technological capabilities. While the idea of falling into a black hole is captivating, it remains a hypothetical subject. Understanding black holes and their mysteries will continue to intrigue us and reveal more about the nature of our universe. Falling into a black hole is not a concern today. However, the fascination with what happens inside persists.